Imagine this. On day 1, you run 24 miles. Then each day, you push harder, adding 7 more miles than the day before. Now fast forward, what if you wanted to know exactly how many miles you'll be running on day 133 without listing every single day? Sounds like a lot of work, right? But hidden inside is a powerful math idea, one that helps us add up numbers faster than any calculator. Let's unpack how arithmetic progression makes this possible. Take a look at these numbers. Notice each set follows a repeating pattern. The 3 dots tells us it continues in the same way. Check this for example. It consists of repeated addition of 3. Knowing this, we can find more times. 11 plus 3 we get 14. 14 plus 3 equals 17. Plus 3 we get 20. This goes on. This set follows a rule which can be used to generate more members, making this set a sequence. So, what is a sequence? A sequence is simply an ordered list of numbers, and each number in the list is called a term. We usually label them this way, where a sub 1 is the first term, a sub 2 is the second term, and we have a sub n for nth numbers of them. There are many types of sequence in maths, but some of the most common ones include arithmetic sequence, geometric sequence, Fibonacci, and cubic sequence. But in this video, we will be focusing only on arithmetic sequence. Now, how do we find any term from a sequence? Say we want to know what the 34th term of this sequence is. It could take a long time trying to work it out, but there's an easier way out. By finding the nth term of the sequence, which is a formula that we can use to find the value of any term without having to write out the whole list. Here, 3 is the first term, or a sub 1, 6 is a sub 2, 9 is a sub 3, and so on. But we want to find a sub 34 without listing all the way down. Consider the sequence 3, 6, 9, 12. Let's map each term to their position n. First term n equal 1, 3 equal 3 plus 0 times 3. Second term n equal 2, 6 equals 3 plus 1 times 3. Third term n equals 3, 9 equals 3 plus 2 times 3. Fourth term n equals 4, 12 equals 3 plus 3 times 3. Nth term t sub n equals 3 plus n minus 1 times 3. So if t sub n represents any term, the formula for finding any term of the sequence 3, 6, 9, 12 is t sub n equals 3 plus n minus 1 times 3. We can simplify this further. First, expand the expression. Now simplify. Then n equals 3n. Now let's run a check. When n equals 1, we get n equals 2, we get n equals 3, n equals 4. So the fifth term is 3 times 5, which equals 15, and the 37th term would be 111. Now that we know how to find the nth term, try solving this. Given t sub n equals 3 minus 3n squared, for the first term we get, for the second term, the third and the fourth. Now that we understand sequence, let's zoom into one powerful type, the arithmetic progression, or AP for short. So what is arithmetic progression? It is a type of sequence generated by repeated addition or subtraction of a constant number to a term. This could be 2, 5, 8, 11, or 3, 1, negative 2, negative 4. Here 3 is added to get each new term, and here 2 is subtracted. Now the first term of an arithmetic progression is represented by small letter a, and the common difference, which is the number added or subtracted to get each new term, we write as d, which is 3 in this case. Now, an important thing to note is that the common difference between each new term is constant. For example, 5 minus 2 should equal 11 minus 8. We are subtracting the previous term from the one that comes after it. In other words, right minus left. Now try finding the common difference for the second sequence. Now that we know this important bit, it should help us find the nth term of an AP. So how do we find the nth term of an arithmetic progression? An intuitive way of doing this is working backwards. So the first term is A. The second term is the first term plus the common difference. The third term is the first term plus the common difference plus the common difference. The fourth term is the first term plus the common difference plus the common difference plus the common difference. Now, instead of adding the common difference repeatedly, we can take advantage of the fact that multiplication is repeated addition. So this is d plus d, which is 2d, and d plus d plus d, which is 3d. Now for the nth term, here's the trick. If you want the nth term, you haven't added d nth times. You have added d n minus 1 times. Why n minus 1? Because the very first term starts at a. No d has been added yet. So the second term adds 1d. The third adds 2d. And by the nth term, you have added d n minus 1 times. And that's why the formula is t sub n equals a plus n minus 1d. It's just our starting point plus all the steps we've taken to get there. Hopefully, this formula is now familiar. Let's try this out with actual numbers. Let's find the 20th term and the nth term. So we use the formula t sub n equals a plus n minus 1d. We are given the first term a as negative 9. The common difference 3 minus negative 3, and that is 6. Let's plug that in. 20 minus 1, 19. 19 times 6, 114. Negative 9 plus 114, 105. Alright, let's find the nth term. Using the formula, now plug in the known values, distribute the 6, and combine like terms. We can verify this by checking for the first 4 terms. When n equal 1, 6 times 1, 6, minus 15, negative 9. N equals 2, 6 times 2, 12, minus 15, negative 3. For n equals 3, same case, we get 3. Now here is a familiar example. Find the 8th and 13th term of the sequence. Pause the video, take your time and give it a shot. Write out the formula, plug in the known values, replace a with 6. Now find the common difference. 11 minus 6, this gives us 5. So we add this and solve. 8 minus 1, 7. 7 times 5, 35. 6 plus 35 gives us 41. So we already have the common difference. Let's solve for the 13th term. Place in all known values. Subtracting this gives us 12. 12 times 5, 60. 6 plus 60, and the answer is 66. So that's how you can find any term in a sequence just by knowing the first term and the common difference. But what if we are given a term somewhere in the sequence and we have to figure out the common difference instead? Well, we can do that as long as we know 3 things: the term itself, its position in the sequence, and the first term. Let's say 47 is the 9th term and the first term is 7. What's the common difference? Pause the video, take your time and give it a shot. So anytime you are given a term and asked to find the common difference, just plug in the known values and solve for d. 7 is the first term, so a equals 7, then t sub n is 47, and n equals 9. Let's solve for d. First, work out the brackets, subtract 7 from both sides, divide by 8, and the common difference is 5. So that's how arithmetic progressions helps us solve patterns. If you recall our one example from the start, adding 7 miles each day, instead of adding day by day, We use a formula that captures the pattern and gets us the answer instantly. Now, can you figure out how many miles they would run on the 1 to the 3? And if you're curious about the total miles by the 133, click the video on your right. We will use series to break it down fast and simple.